Okay, so next we are going to discuss is block versus stream ciphers. So these two techniques we have already discussed in one of the previous classes. So why are we discussing it here again? Because we'll be using these block ciphers for the upcoming ciphering techniques, right? So that is why I am just covering these two topics here, just to revise it. Okay. So block ciphers, they process the messages in blocks, as I already told you, and that we consider the plain text as blocks, and we process each block. We cipher each and every block. We encrypt each and every block separately with some value of key. Okay, and here in the upcoming ciphering techniques, we'll be using blocks of size 64 bits or more. In contrast to it, there are stream ciphers in which we process the messages bit by bit, or we can also consider at some places you can also find processing of the messages with respect to bytes, not bits. Okay, so a bit or a byte will be processed at a time while encrypting or decrypting the messages. So for the upcoming ciphering techniques, we'll be using these block ciphers because their applications, the range of their application is broader as compared to stream ciphers. So that is the main reason of using block ciphers over stream ciphers. Now this is again the same thing. So symmetric key cryptography we are discussing right now. So these techniques which we are going to discuss, they come under modern block ciphers. So the basics will remain same, and instead of using characters, because in previous techniques we have used A, B, C, D, these characters we have used. So instead of using these characters, we'll be using and now bits. Okay, and in bits, as you all know, we'll be making use of zeros and ones. So we'll be considering these n bit block of plain text, and we will be decrypting this n bit block of plain text into n bit block of cipher text. Okay, and for converting it or for decrypting the plain text, we'll be using a k bit key, right? So this key will be used for encryption as well as for decryption. This is the representation for n-bit plain text encryption and decryption. So herein, instead of using those characters A, B, C, D, we are using n-bit plain text. We are encrypting it and we are getting n-bit cipher text as the result. And here we are using this k-bit key. So the same thing is represented diagrammatically over here. At the decrypting end, we have this n-bit cipher text. We are decrypting it and we are getting this n-bit plain text. Now, if our message has fewer than n bits, okay, here we are discussing about these n-bit plain text. If the plain text has the bits which are less than n bits, then we make use of padding. Okay, so we'll be padding the bits in the last block, because I've already told you that we'll be using blocks for encryption and decryption now. So we'll be creating blocks out of plain text, and if the last blocks if the last block, say it becomes short of bits, then we'll be adding extra bits to it to make it this n bit block. Okay, so padding must be added to the last block to make it n bit block. And this n, the value of n could be 64, 128, 256 or 152 bits. So generally we make use of this 64 or 128. Okay, so and in most of the cases we use 64 bits to consider a single block. So the block size will be 64 bits in most of the cases. So these are some components of modern block ciphers. So they are, the keyed substitution ciphers, in which the key allows only partial mapping from the possible inputs to the possible output. So in this we'll be discussing these two things, which are substitution and permutation. The substitution, as we all know, we have discussed two kind of ciphering techniques, substitution and transposition. So substitution is same, wherein we substitute one character with another character, and permutation is it is in correspondence to that transposition ciphering, wherein we reorder the given characters, or the bits will be using. Okay, so substitution and permutation, these two ideas we will be using, and these ideas were proposed by this Claude Shannon. Okay, and we call these ideas, which are of substitution and permutation, we call them as S box and P box. S for substitution and P for permutation. So these are cryptographic operations which we have already discussed in previous class. Okay, so again we'll be using them over here, and out of these two, mainly we make use of substitution, right? So I'll tell you the reason for that also. Two more concepts which we'll be discussing are confusion and diffusion. Okay, so these are important concepts to understand, better understanding of the upcoming cryptographic algorithms. So first we'll be discussing these P boxes, which are, these permutations. So this P box or the permutation box, it parallels the traditional transposition cipher, as I already told you over here. These two techniques we have already discussed, this substitution and transposition. So in transposition, what do? We simply reorders. We simply reorder, or we change the position of the given the characters of the plain text, right? So here we'll be dealing with the bits, so we'll be changing the position of the bits only. So it transposes the bits. तो bit को जैसे हम लोग यूज करेंगे तो उसका ट्रांसपोज यहाँ पे हम कर सकते हैं. So कैसे करते हैं वो हम आगे देखेंगे अभी. So three types of P boxes we can have: straight P box, compression P box, and expansion P box. So based on the number of inputs and outputs, these three types of P boxes are available. In straight P box, what do we have? Say for example, this the number of inputs are n and the number of outputs are m. If n and m are equal, then the P box is called straight P box. Okay, and each and every n will be connected to one m, right? So that is why these values are same, and the value of n and m is same. In compression P box, the value of n and m are not same, and the value of n is greater than m always. Okay, so we call it compression P box. In expansion P box, what happens? This value of n is less than m. Okay, so the number of inputs are less than the number of outputs, and more than one input is connected to one or more outputs. So here you can see this one is this giving output as 1 and 4, this 2 is giving output as 5, and 3 is giving output as 2 or 3. So these are permutations, right? So these are three type of P boxes which we have. Now this example shows all 6 possible mappings of a 3 by 3 box. So it simply shows you the connections. जैसे इसके अंदर direct connections हैं, 1 is for 1, 2 is for 2, and यहाँ पे 1 is for 2, 2 is for 1, 3 is for 3. So these kind of connections, these kind of 6 possible mappings we can have for inputs and outputs. See, these things are just important to understand, right? So that is why I'm covering all these things. But the important things which we need to understand are the concept of confusion, diffusion, and the concept of p boxes and s boxes, because we are going to make use of these concepts in the upcoming topics. Next, we'll discuss this invertibility of P-boxes, because at the decrypting end, we make use of the inverse of key. Okay, whether it is addition operation or multiplication operation, so we make use of the inverse of key. So the technique which we are using at the encrypting end must be inversible at the decrypting end. So only then we'll be able to decrypt the message. So it says that the straight P box is invertible, but compression and expansion P boxes are not invertible. Okay, so I'll show you with example. So it is showing the inversion of a permutation table. So this is the same process, if you people remember, जो हमने ट्रांसपोजिशन में किया था कि हम डिक्रिप्टिंग एंड के लिए हम की कैसे फाइंड आउट करेंगे, right? So that is the same thing over here. Say for example, this is the original table we have, okay, at the encrypting end. So to find out the value of this particular table for the decrypting end, what do? We add indices first of all. Okay, for all these values we number it from 1 to 6, because 6 values are there in this table. Then we swap the contents of the table and the indices which we have added, and then we sort it. Okay, so if you people remember, we have used this same method in the transposition technique, which we have already discussed in one of the previous class. So after sorting the value of indexed indices and this table, what we have got is these entries for the table. Okay, so this is the table which we will be using at the decrypting end. So we call it as inverted table, right? So this is how we inverse the straight P box. And it shows that the compression and expansion P box are non-invertible because the number of inputs and outputs are not same. So that is why this problem is there is this problem of not being able to inverse the given P box, right? Next comes S box, or which is called substitution box. It can be thought of as a miniature substitution cipher. Okay, so the process will be same. We'll be substituting the bits. Okay, so it says that an S box is an M by N substitution unit where M and N are not necessarily the same. So the value of M and N, it is not necessary that the number of inputs and outputs which we are having, they must be same. It is not necessary. Okay, so this is an example of an S box which is linear. Okay, so it is showing that these are outputs, see, y1 and y2. So these two outputs we are having, and the number of inputs in this is x1, x2 and x3. So two outputs and three inputs we are having, right? So here as it says that these m and n, they are not necessarily the same. So this is an example of a linear S-box, and this is the example of non-linear or a polynomial S-box. So these are polynomials which we have discussed in previous classes. Okay, so we will be making use of these kind of S-boxes. So this is in this form, the Galois field, right? So because we are using polynomials over here. So here also you can see we are having these two outputs, y1 and y2, and x1, x2 and x3. Three inputs are there, right? So the value of, the number of m and n are not same, and the S box is non-linear, or we can also call it polynomial. Next is this table, which defines the input-output relationship for this S box of size 3 by 2. Right, so here 3 by 2 means we are having 3 inputs and 2 outputs. So how do we make use of this table? Now it says that the leftmost bit of the input defines the row. जो भी leftmost bit होगी input की, because this input is of 3 bit over here, so the leftmost bit will be used for the rows, and the two rightmost bits of the input will define the column, right? So input will be made up of this bit and these two bits. Okay, so if I am concerned about this entry, so that means I am talking about the input which is made up of this entry and this entry. Okay, so the input will be 0, 0 and 0. Okay, and its corresponding output will be this one, which is 0 and 0. So one more example is given over here. You can see if the input is 0, 1, 0, that means the leftmost bit you have to check it in the row, and the two rightmost bit you have to check it for in the column. So 0, 1, 0, it takes you from here, this 0 is over here and 1, 0 is over here. So for 0, 1, 0, the output will be this one, 0, 1. So it says the same thing, that this input 0, 1, 0 yields the output 0, 1. And the input 1, 0, 1 yields the output 0, 0. So here we can check the leftmost bit is this one, 1, and 0, 1 is over here. So for 1, 0, 1, the output is 0, 0. Fine, so this is how we make use of this table while using S boxes, okay, which are having a different number of inputs and different number of outputs. Now this is a single table. We can have the inverted table as well for making use of it at the decrypting end. So this is an example of invertible S box. So this is the table, the inverted table, which is used for decryption, right? So input is of 3 bits over here, and output is again of 3 bits over here, right? So here the value of m and n is same. So in this example is given, say if the input to the left box is 0, 0, 1. So our input is 0, 0, 1. So we have to check it for here, check for it over here. This is 0 and 0, 1. So 0, 0, 1 gives you 1, 0, 1, right? So this will be the output, which is written over here, 1, 0, 1. Now at the decrypting end, our input will be what? It will be 1, 0, 1, right? Because this is the message which we have encrypted out of 0, 0, 1. So this will be say we call it cipher text, right? So or the encrypted messages 101. So when we decrypt it, we should get the original message, which is 001. So we'll use this table for decrypting the message. So our message is 101 now. So 1 is here, 101 is here. So the output we get is 001. So this is same as our input. Okay, so this is the inverse S box, or the invertible S box, right? So we can say that these two tables are inverses of each other, right? So we have to find the inverse of the given key, whether it is in form of S box or P box or any other form. जैसे हमने previous examples में भी किया था, key चाहे किसी भी form में हो, for decrypting the message we have to find out its inverse, right? Next comes this exclusive OR operation, which we have I've told you how do we perform it with the polynomials. So we'll be using this XOR operation because we have used this operation for subtraction as well as for addition. Okay, so while using this operation we consider both the operation as same. Okay, जो हमने previous classes में भी किया था, जब भी हमने polynomial addition किया या division के time पे जब भी हम subtraction कर रहे थे, so we were performing it just like addition. So this XOR operation is also invertible, right? So it says that an important component in most block ciphers, so as I already told you, we'll be making use of block ciphers as of now. So as we discussed in previous chapter, that this addition and subtraction operation in Galois field 2 raised to n are performed by a single operation, which is called the exclusive OR. Okay, so these both of these operations are performed with this single operation. And this operation it also holds these 5 properties जो हमने axioms हमने discuss किए थे fields के लिए या groups के लिए, which were closure, associativity, commutativity, identity, and the existence of inverse, right? So we can achieve all these properties while using XOR operation with fields, right? So all of these things we have already covered. Now these are some more operations or components, you can say, which we'll be using in upcoming ciphering techniques. One is circular shift. So circular shift में we can have a left shift or right shift. So this is an example for left shift by 3 bits. So इसके अंदर हम लोग क्या करेंगे, will be shifting 3 bits to the left. So ये वाली जो bits हैं वो हम लोग shift करेंगे, तो जो shifting के बाद हमें जो result मिलेगा, this will be the result. So here you can see we have shifted these 3 bits, right? For shift right, we'll be shifting these bits which are at the right position, right? So all these operations you might be knowing. Next is swapping. Swapping operation, it is a special case of circular shift operation where this k is equal to n by 2. So swapping में हम लोग क्या करेंगे, will be dividing this whole bit, whole this the number, total number of bits we have, we will divide it into half and then we swap their position. So here you can see this B0 to B3, they are at left position. Okay, after performing this swap operation, initially they were at the right position, and these 4 bits are at the right position now, which were initially at the left position. So at the decrypting end will be just reversing the process. Okay, the bits which are at the left will be taking them to the right, and the bits which are at the right will be taking them to the left. So this is swap operation on an 8-bit word, right? Next is split and combine operation. Split and combine में what do? We split the word at the encrypting end and then we combine the word at the decrypting end, because after all, after decryption we need the whole plain text. Okay, so this is the initial plain text. Here we'll be splitting it, okay, into here in this example we have split it into two parts, and at the decrypting end we'll be combining these two parts which we have splitted at the encrypting end. Right, so this is another operation which is called split and combine. So we have discussed this shift operation, swap operation, split and combine operation. Right. Okay. Next comes this product cipher. Now product cipher, what do we do in this? We combine a number of techniques which are substitution, permutation, and other components which are circular shift, swapping, and all other things which we have discussed in previous slides. So product cipher make use of all these things which we have discussed till now, right? So इसी के अंदर हम लोग confusion और diffusion को discuss करते हैं, right? As I earlier told you, because these two concepts will be using. So first comes this diffusion. So the idea of diffusion and confusion was given by Shannon, okay, who gave the idea of these S-boxes and the P-boxes. So the idea of diffusion, it says that we need to hide the relationship between the cipher text and the plain text. Okay, so this relationship between them, it must be hidden so that the attacker could not it should not be able to find out the value of p, right? So and as a result, the attacker should not be able to intercept the message. So diffusion, this property hides the relationship between the cipher text and the plain text. Okay, so three main things we have when we talk about cryptography. One we have is plain text, then we have key, and then we have cipher text. Okay, so in diffusion we talk about cipher text and plain text. Next comes confusion. In confusion we talk about cipher text and the key. Right? In diffusion, we hide the relationship between cipher text and plain text. And in confusion, we hide the relationship between cipher text and the key. So the idea of confusion is again, it is to hide the relationship between the cipher text and the key. So don't get confused in these two terms. Diffusion talks about cipher text and the plain text, and confusion talks about the cipher text and the key. So the relationship must be hidden, because if the relationship comes out, then the interceptor or the intruder will be able to decrypt the message very easily, right? So these two concepts we need to understand before moving forward, right? Okay, I think that's all for now. इसके बाद फिर हम नेक्स्ट क्लास में करेंगे, बिकॉज यू उसके आगे विल बी discussing one very important structure which is called feastal structure. Okay,